solve each logarithmic equation. I see that I have 3 logs in this problem. I need to condense. First of all, let's condense on the left side. I'm going to condense down to one single logarithm, log. I have a plus sign. The sum came from the product. So therefore, I have x minus 2 times 5. I'm going to put the 5 in front. X minus 2 equals 2. I could have put the 5 at the back. Okay. Equals to log of 100. Now, I see that I can evaluate log 100. Log has an understood base 10. 10 raised to what power would give me 100? That would be 10 times 10, which is 100. We know that 10 squared equals 100. Therefore, I can evaluate this whole log here down to 2. So I have log 5x minus 2 equals 2. Okay? So now that I have it down to one single logarithm, I can change it to exponential. So here, log, I could go ahead and distribute if I wanted to. I have log 5 times x would be 5x. 5 times negative 2 is negative 10 equals to 2. Now let's change it from logarithmic form to exponential since I've got it down to one log. Now remember, log has an understood base 10. So converting this to exponential, you have your base 10 raised to your exponent 2 equals to 5x minus 10. In this problem, I only had one log, so I changed it to exponential. Well, 10 squared is 100 equals to 5x minus 10. Continue solving for x. Let's add 10 to both sides. The 10's cancel here. I have 5x equals to 110. Okay? Next, solve for x. Divide both sides by 5. So if you punch in your calculator 110 divided by 5, you end up with x equals to 22. Okay? X equals to 22. So we'll need to check and make sure that this answer does not require us to take the log or ln of a negative. If you plug in 22 here, 22 minus 2 would give you 20. So that's asking us to take the log of a positive. This is the log of a positive. That's the only time we had to plug in 22. And so therefore, if I was to check this out to see if the left side equaled the right side, it does. So therefore, the only answer for this problem is x equals to 22. Just remember, you cannot take the log or ln of a negative number. So if it ever asks you to take the log or ln of a negative, you have to exclude that number from the answer. All right, let's look at another example. We have log x plus 3 plus log x minus 2 equals to log of 14. So again, I have 3 logs. Let's condense. Here, if I condense this down, this is a sum. I condense it down to a product of x plus 3 times x minus 2 equals to log of 14. I cannot take the log of 14. I cannot evaluate that. It has base 10. There's not a power that 10 can be raised to give me 14, so therefore I cannot evaluate the right-hand side here. So we will use our one-to-one property. I do have log on the left side equal to log on the right side with coefficients of 1. So therefore we will remove the logs and we will write it without the logarithm. So we will write x plus 3 times x minus 2 equals to 14. Now let's solve this. On the left-hand side, I need to FOIL. X times x, x squared. X times negative 2, negative 2x. 3 times x, 3x. 3 times negative 2, negative 6 equals to 14. This is a quadratic equation since I have the x squared. So I need to get everything on one side set equal to 0 so that I can factor. or use the quadratic formula. So let's subtract 14 from both sides. So I end up with x squared. Negative 2x plus 3x is 1x. Negative 6 and negative 14 is negative 20. So now let's factor. We factor x squared into x and x. The back sign's negative. Signs are going to be different. Your factors of 20 are 1 and 20, 2 and 10, 4 and 5. Which pair of these numbers, when you subtract, do you get the positive 1, 5 and 4? I need to give the sign that I want, which is positive, to the larger number. So I'm going to use positive 5, negative 4. You can double check me by going back and foiling and make sure that when I foil these two binomials, I go back and get what I started with, and I do. Now, you can set each one of those equal to 0 and solve for x. So let's add 4 to both sides. I have x equals to 4. Let's subtract 5 from both sides. I get x equals to negative 5. Now, so let's check these. If I go back and plug in 4 into the original problem, 4 plus 3 is positive 7. That's good. 4 minus 2 is positive 2. That's good. And actually, if you check this out using your calculator, 4 would work. 4 required me to take the log or ln of a positive number. Now let's test negative 5. If you plug in negative 5 right here, what's negative 5 plus 3? Negative 2. We cannot take the log of a negative number. So I know that I have to cross out negative 5. So the only good answer to this problem is positive 4.